I want to welcome everybody to the translation of technologies into space track. One of the challenges that we see often is that there's some really great tech, there's some really needing requirements, and then how do you put those two together? And so that's a little bit of what we'll talk about today. Today we have four panelists on the call here. Lieutenant General Shaw will be up first, who is the Deputy Commander of United States Space Command. Jordan Noon, partner of Embed Ventures and co-founder of Relativity Space. Mark Matosian, Solstar Space co-founder and advisor. And then finally, Jason Ballard, co-founder and CEO of Icon. So welcome to all of you. We will have some time at the end of the session for some Q&A. So for the audience members, feel free to throw into the chat some questions that we might be able to address. And with that, I'd like to begin with General Shaw, who is no stranger to the national security space sector. 3 decades of experience in this sector, now at United States, the newly reformed United States Space Command. And General Shaw is, from day one almost, has seen how warfighting has benefited and evolved, from the space services that were, some ISR, certainly GPS capabilities coming online when you'd first come into the service, to where we are now and what you've heard about what's going on from the last panel with respect to how space can provide some of those solutions that JADC2 is looking for. So, General Shaw, can you maybe briefly talk about some of the challenges and opportunities you see, particularly at Space Command, but certainly your career and your perspective, since you are the operational arm of the DoD space community there.
Hey, thanks, Chirag, and good to connect with you again. Hey, thanks to Microsoft for hosting this particular part of the program, and hello to Fed Supernova, and United States Space Command is really thrilled to be part of this. So thanks for having me on the panel. Hey, I think the best thing I can do is just sort of set the stage a little bit so you hear some real experts on technology here and its applications to space to tell you kind of what we need. So I'm excited to be part of 2 startups. I'm now a member of the United States Space Force and also the Deputy Commander U.S. Space Command, and they are organizations that are both over just a year old. So we're growing along with many startups in the tech community, and we're faced with many challenges. So what I'm going to do real quickly is I'm going to outline to you 3 challenges we have, and here they're highly technical in my assessment, so bear with me, okay? The first one is space is humongous. So we're finding as we're looking out into space, as it's potentially dealing with threats in the space domain, we're looking out as far as the cislunar sphere right now, eventually it'll be further. That is a lot of volume to cover. How do you know what's going on out there? Especially when there might be those that are trying to avoid being detected or avoid letting you know what's going on out there. And I think the answer is going to be a big data problem for years and years to come. Many, as we've seen here in the terrestrial spheres. We're going to have lots of sensors. Some are going to be on the planet, some will be out in space, and they'll be looking at various, whether they're optical or they're radio frequency or passive or whatever, they're going to be looking out in the space domain, and we're going to need to fuse all that data in a big data manner, use analytics and algorithms to understand what's going on, and then present an operational picture to my boss, General Dickinson, and a picture to our national security leadership and to other space users. It's a big data problem. So any of you that are working big data problems, we are interested. Space is interested. The second is space is hard on humans. It really is. We look at our manned space program and, they don't exactly go up there in just flight suits, right? It's tough on humans. And so when we look at doing operations in the space domain for years to come, particularly for national security needs, we're going to be relying on robots, on drones, on machines. Now, I'm fond of saying that I think the best robots that humankind has ever created are probably our space exploration vehicles, and NASA's Perseverance might be at the top of that list. At least it would be today in terms of popularity. It takes a lot of thinking, a lot of ingenuity to put something that can operate autonomously very far in very austere environments. As we progress further in the space domain for whatever purpose, civil, commercial, scientific, national security, the robotics arena is going to mean a lot to us. We're going to need platforms that can operate autonomously, that can incorporate machine learning, artificial intelligence to do whatever activities we've asked them to do. So for those of you that work in that sector, space is interested in you. And lastly, I'll say that in space, nobody can hear you scream. Well, we know that, but what I'm talking about is satellites actually don't hear each other. They don't talk to each other. What we actually have going on in space today is similar to the way terrestrial communications worked before the ARPANET. You basically have point-to-point communications. Either it's satellite to ground and back up to another satellite, or just satellite to ground to ground. Satellites rarely talk to each other unless there was some sort of built-in relay connection that was programmed into the start of a system, and even then it's serial in nature, right? It's kind of strange when you think about it. You might have two commercial communication satellites at geosynchronous orbit that are within a few dozen kilometers of each other operating, and yet they can't talk to one another. They're basically talking to their controllers on the ground who talk to other people on the ground to try to make sure they don't run into each other. When are we going to get to the point where satellites can communicate with one another and do so without having been designed as part of that system? Pretty much think of it as a Wi-Fi in space, or an internet of space things. We're going to need something like that in the future too, especially as we go further and further out into space. The comm delays by the speed of light reaching back to the Earth really make it nonsensical for platforms further and further out to talk to one another. They're going to have to do it. So those of you that are working on networks, communications networks, maybe you're focused on things in the terrestrial domains, but space is interested in what you have to bring as well. So that's my introductory pitch. I want to see what our panelists have to do to answer those kinds of challenges that we're looking up here in space, and I really look forward to your Q&A. Thanks, Chirag.
Thank you, General Shaw. And I think if you're able to stick around for our space startup pitch competition at the end of this, you might be surprised to see some of your answers are actually being addressed as we speak. So hopefully in the not so distant future, you will have them. So let's move over to Jordan Noon, who's currently the CTO and partner at Embed Ventures. A lot of you know him as the co-founder of Relativity Space. I think Jordan exemplifies the fast and exciting pace of the new space community. His career has basically been burning as hot as the rockets he was developing over at Relativity. So, hey, Jordan, welcome to the panel. You've been at the forefront not only of some of the successes of the space startup community, but some of the growing pains of working with other companies, working with bigs, working with particularly with the government. It'd be very interesting to hear from you kind of the path that you've experienced and kind of where we need to go from here.
Thank you. And hello, everyone. Happy to jump into all of those areas. As far as my background, starting really with Relativity, co-founder starting in December of 2015 with Relativity Space with the vision and mission to 3D print the first rocket on Mars and having to do the first step of learning how to do that on Earth. We developed the world's largest metal 3D printers, using those for a variety of applications, including a commercial rocket launch vehicle named Terran 1. We're using that for a variety of applications for customers, including a recently announced DoD contract this morning. So excited to be able to comment on that here. But we really set out with the vision of being able to accelerate the rate of innovation in aerospace. It's something where the aerospace design cycles have lengthened and lengthened over time, especially on the rocket launch vehicle side, something that we were very disappointed to see even in our former careers for my co-founder, Tim, and myself, where we wanted to see the rate of innovation change. And the way we saw that happening was through introducing 3D printing, specifically large-scale metal 3D printing, to the aerospace manufacturing community. We faced a lot of challenges in the 5 years in between founding the company and now. The area I'd want to highlight the most is the challenge of getting venture capital investment in areas like deep tech, areas that have advanced manufacturing, materials development, anything with really a scientific or technical breakthrough, which really dithers from the direction that the venture capital community, at least here in the US, has gone, where you see more and more venture capital going into startups that have low technical risk, have low capital requirements, that are high margin. And those are generally SaaS companies. They're companies that are for consumers. They're enterprise software startups, but they are not startups that have relevance to the national security sector. And that's something that's very worrisome to me, especially as you look at the short timelines and short horizons that these investors are looking to get returns on. There's a bigger and bigger migration every year away from hardware projects and away from projects that have national security relevance within the innovation community. Relativity was very lucky in that we were able to fundraise, we were able to thrive despite those limitations. And where I want to take the rest of my career post-Relativity, I stepped out of my full-time role there in September to launch Embedded Ventures, was to really support the next generation of startups looking to develop national security solutions, the ones that General Shaw was talking about, as far as what does it take to get those projects off the ground, get them support from the investment community in a way that is often very limiting. And as far as the venture capital available today, the reason I mention that is you look at companies like SpaceX. When SpaceX first got stood up, there was very little external investment going into launch. And once SpaceX hit that commercial inflection point, say in 2010, you see the rest of the venture capital community starting to chase the launch opportunities. But it took that first mover with Elon and SpaceX to get over the hump almost on their own in order to see the rest of the venture community want to invest in space, in launch. And there's a ton more areas that need that same first mover to be successful. And we want to be that example for the venture capital community with Embedded, specifically to get those companies off the ground, get them working with DoD, get them prioritizing national security solutions, and use our team here to de-risk those companies to the point that the rest of the venture ecosystem will invest in them and get them through that commercialization hump. But something that independently, from our perspective, there are programs like AFWorks, SoftWorks, SpaceWorks getting stood up, all the work at DIU that have been very successful in accelerating the ability for DoD to work with startups. But I think the venture capital community has to take that same initiative where we can carry those companies to the point that they can work with current DoD. They can work with, phase 3 contracts. They can get an IDIQ contract. But something where you need the private investment community to have that same conviction the DoD has to drive these companies and startups to the point that they can work with DoD at a full scale. And that is very much missing in the environment today.
Hey, Jordan, those are great comments. Question for you, actually, and panelists, I forgot to mention this up front. Feel free to, fire across as you feel. But I'll start real quickly here with one here, Jordan, is how much does it mean, even if by the smallest token of interest or investment by the Department of Defense into a startup to the VC community? Even it seems as though just that the token of expression of interest seems to be a lot, but I don't know if that often translates to the department or not.
It definitely adds a lot of value to the startup. The concept of government as an anchor customer has been something that has been around for quite a long time. And startups look at that for securing, a de-risked growth plan where some of that is highly stable government contractual capital. Once that contracting opportunity is in place, it's sometimes a very heavy lift to get that opportunity in place and to secure that. But that stable capital, that stable, kind of customer growth opportunity with the government is one that adds a lot of value to the startup. The question that I'd ask back when you see that kind of anchor contract hit a startup and the ability for future venture capital to be de-risked by having a government anchor customer, what actually incentivizes the startup to prioritize, let's say, a national security solution? And that's where I see things start to diverge, is you see startups get anchor contracts from the government through groups like DIU that do quite a bit of very high quality work, right, in order to get DoD to be able to work with these small scale companies. But then future venture capital comes in because of the de-risked opportunity. And what incentivizes or requires the startup to deliver on time, to prioritize that national security solution over what can be a very much easier growth path by tackling the commercial markets, right? If you have a growth path through commercial opportunities, you have a growth path through defense opportunities, the commercial ones are often, if not almost in every case, easier to tackle. So you see with the venture capital short-term pressures coming in, further investment built on top of that anchor kind of optical opportunity there. Do you actually see the startups delivering on all of that hard work done by DIU, done by DoD to make these contracts happen? And they do eventually, but I don't think it's done in a sufficiently prioritized manner to be sufficient for current national security needs. It's almost an afterthought once that further venture capital comes in.
Yeah, I would chime in that a government contract for startup can be a super important validation, but the perspective of the VC community is it's just fundamentally oriented still towards scale and commercial markets, and that's why where Jordan's orientation on this VC firm is so exciting, is that I think government contracts, they provide a validation service for that community, but they don't look at it as as a business that can grow and hit their 10x, their 100x ideal growth for the venture. They're still looking to the commercial side for that.
Yeah, and to add on to that, that was very, very well phrased, Mark. I think the view, and to summarize it, is those contracts are specifically used as validation. They're not used as accountability or responsibility to the national security sector. And that's something that's very tricky when you have all of those short-term venture capital pressures on top of these startups, where the board is driven towards short-term returns, short-term returns for their funds. They're not accountable to the national security sector, despite growing on top of the optics and all the hard work provided by DoD.
Yep.
That is really insightful, and thank you both for those comments there. So, Mark, speaking of Mark here, Mark Matosian, Solstar Space co-founder and advisor. Mark has got a long, just getting to know him, has a long career in all kinds of fun, interesting, groundbreaking, game-changing space stuff, from Cold War space solutions to the first generation, so to speak, of proliferated LEO SATCOM. When you think about like Teledesic, Iridium, more recently, areas that I've grown to love very deeply, data, AI, cloud, in remote sensing GEOINT constellations. Having come from NGA, I think that promise of the GEOINT revolution has been knocking at the door for a few years now, particularly with recent contract awards and increasing non-traditional opportunities here. But I'm just curious, are we quite there yet? From your experience, Mark, with the SATCOM community, the remote sensing community, are we falling into bad habits that we've maybe forgotten about in the past, or what's different about now? Between all the different environments that you've experienced that shows promise for the future.
Wow, that was a mouthful. I would say it's absolutely different this time. This is I think of the Iridium Teledesic period in the 90s as sort of telecom constellations 1.0. And now we're very much in a constellation 2.0 kind of environment. And things are fundamentally different now. First, clearly, launch costs have dropped. There are now CubeSat and SmallSat standards that allow for just a much more rapid movement in engineering development and schedules. Costs are down. And then, of course, a big accelerator here is the cloud for processing in the case of GEOINT. So I think it's a very different environment. Part of the question is, are the customers ready? And you have to separate telecom and remote sensing GEOINT. So on the telecom side, it's not just Starlink and some of the other broadband ventures that are getting going now. I would say some are tripping and some are getting going, like Telesat Lightspeed had a recent announcement. Also, you have smaller entities that I think are very exciting, like Kepler Communications, that really fully embraces the small sat new space mentality. And so I think there's going to be a lot of opportunity, and specifically in telecom, to realize much more of that Wi-Fi in space that General Shaw mentioned earlier, particularly in LEO and the company that I co-founded, Solstar Space. On the GEOINT side, though, I think it's an interesting question, and you have to slice it, because you have optical, which I think is almost getting commoditized now with Planet and Black Sky and others, and that's a good thing. And so that's now getting folded into a greater procurement path. Synthetic aperture radar is hopefully right behind it. It's been a slower development, but the synthetic aperture radar revolution is well on the way now. Well on the way. And then right behind that is, of course, ELINT with Hawkeye 360. And if you want to look around the corner, because we're also talking about the future here, there are some very interesting things brewing with hyperspectral. So I think that's going to be a very exciting opportunity. But I would stress, especially for that GeoInt side, this is not your father's GeoInt constellation now with cloud, because cloud enables so many things, and also the supporting infrastructure around it. Commercial ground link networks, ground station networks, terrestrial fiber build outs that allow for relays, scalable computing for on-demand image processing, the machine learning and other AI techniques for image analytics and things like object identification. And then cloud storage and cloud distribution out to the customer. So I think General Shah previously has described space as elemental carbon, as that, that fundamental biochemical building block for life. And I think, and I fully agree, but I think it's that cloud, space plus cloud, the capability that enables is extremely exciting.
That's great, Mark. I think one area that I think is challenging, and I'll maybe even ask General Shaw this here in a second about, how do you, I'll give you from my NGA perspective, former NGA perspective, but it'd be interesting to see how this gets into the, into the DoD ecosystem as well, which is, you reference the fact that, satellite imagery is becoming commoditized. And I don't disagree with that. But on the other hand, there's so much of that out there. And it sits out there primarily in an unclassified ecosystem. But where our warfighters often operate are in classified worlds, often in the secret world. And then where the intelligence community often operates is in the top secret world, right?
Yes.
So while there's this beautiful cache of data, being able to integrate it with some spectacular capabilities that the department and the intelligence community brings together is not yet there, it seems. And General Shaw, maybe from your perspective, I mean, is that a challenge that you guys are witnessing from an operational warfighting perspective? Is the development of all these different kind of capabilities out in the open, with merging it with all the kind of capabilities that you've been funded over the past 5 years and plus, how do we bring those types of capabilities together?
Hey, Strug, I think so. I think you're describing an aspect of the big data issue, right? How do we optimally, I think I choose that word with the technical definition to it. How do we optimally invest in unique capabilities that the government's going to need, and at the same time integrate in those that are available commercially, much as Mark has talked about? And how do we do that in an optimal fashion? And of course, there's a flip side to this too, right? That means that potential adversaries we have access to some of that very similar data. So how do we exercise some form of security against that amount of information that might be available? Man, that's a really short answer to a pretty deep question, but I think we cannot be apart from that moving forward. The national security structure is going to be a part of this broader ecosystem moving forward.
Yeah, my recent experience in glimpsing this on the DoD IC side is that, at least in optical, the challenge wasn't so much getting the data. The challenge was in processing and managing the data and doing the analytics and drilling it down into something that's more useful and actionable and can get out to the analyst and the operator, the warfighter in theater.
Awesome. Thank you so much, Mark. And last but certainly not least, and I would say probably most exemplifying the theme of this panel, which is transitioning technologies into space, we have Jason Ballard, who's the co-founder and CEO of ICON. So here's the question, Jason. How does somebody, and ICON is a construction tech company revolutionizing home building using 3D printing, robotics, technology, software, cutting edge material. So Jason, how does somebody who has a company in Austin, Texas, focus on home building, get onto a panel that talks about space industry needs with the deputy commander of U.S. Space Command? And how do we take that technology and bring it to the needs that General Shaw is addressing here?
Yeah, well, first of all, it's an honor to be on this panel for sure. Icon, yeah, we're a construction technologies company, and we are focused on like breakthrough paradigms in leveraging robotics and automation and digitization to accelerate and expand the way that we do construction. Of course, the most immediate application of that technology was here on Earth, right? Like solving a lot of our housing and construction challenges here on Earth. But from the very get-go in this company, we had an eye towards space. My graduate studies were in space resources at the Colorado School of Mines. The very same year we came out of stealth mode, 3 years ago, actually, we first unveiled America's first permitted 3D printed home here in Austin. That very same month, we began participating with NASA in their Centennial Challenge program for 3D printed habitats. I believe, that these sort of things aren't in contradiction, right? I think it's going to be a spacefaring civilization that figures out how to solve homelessness on this planet. And then also like going to the moon and trying to build structures on the moon and to Mars. That's the double black diamond of like robotics and construction, a lot of these things. And so a lot of those insights already, even in the first few years of our work together with NASA, we work with the Marshall Space Flight Center on our lunar work and Project Artemis, developing a construction system that would be capable of delivering all kinds of structures, launch pads, landing pads, roadways, unpressurized structures, pressurized habitats in the lunar environment using local resources, in situ resource utilization. And then we're also more recently working with the Johnson Space Center on similar applications for the Martian environment. Both have like different kinds of challenges, like, Mars has an atmosphere and more gravity and things like that. But already just in like the concepting and early construction and demonstration phases of the technology, a lot of the work is cross-pollinating back into our work on Earth, because space is the double black diamond of autonomy, of resilience, of repairability, radiation hardening, autonomy. All these things get turned up to 11 when you go away from planet Earth. But of course, it makes our technology on Earth faster, stronger, more resilient, more capable. And so you're getting this wonderful cross-functional benefit. I should also say, because of this panel, we have a really fun and healthy and exciting collaboration with the Department of Defense, with the Air Force, with the Defense Innovation Unit, and others there as well. And so, yeah, maybe Icon is this like prototypical example of a breakthrough technology that's truly like a paradigm shift, sort of like what Jordan was referring to earlier, sort of these like deep technologies that involve multiple scientific and engineering breakthroughs. But of course, once you do that heavy lifting, the applications benefit society and in multiple sectors in multiple ways. And so it's been a lot of fun. We hope to have hardware on the moon this decade in partnership with NASA. And we've already done a number of demonstration projects with the Department of Defense. In fact, this weekend, you'll see a press release about it soon, and maybe I'll get in trouble for saying something too soon, but we 3D printed a rocket pad, like a demonstration subscale rocket pad with NASA at a nearby military base. And we did a rocket test fire on the pad this weekend, Saturday, and it went swimmingly. And so we're really optimistic and bearish that indeed these breakthrough approaches to solving some of these problems have real legs, and we're just getting started.
That's amazing, Jason. And since you're the boss, I don't think you're going to get in any trouble for announcing that a little bit ahead of time there. So Jason, Mark, Jordan, and General Shaw, thank you guys so much for being part of the panel. Hopefully, one, we've developed some new connections, two, expose some insights along the way here, and three, hopefully been able to start, peeling back some of those requirements that General Shaw needs to be able to have a successful command. So, sir, I'll maybe turn it back to you where we started, just for a couple closing remarks, and then we'll turn it over to Helena for our next session.
Yeah, hey, appreciate it. Hey, appreciate my panelists, man. We probably could have gone an awful lot longer than 30 minutes with all of this. Jordan, appreciate your insights. I think the fundamental question there is how do we get the VC enterprise to really be able to, and the national security enterprise to really be able to leverage one another in ways that are beyond just validation? If there are ways to do that, I think we're all in on that. I thought Jordan's comments were terrific. He's really making me think more about, a lot of the technologies he's really working hard on are part of a broader autonomous capability set that are going to have a lot of application across the spectrum moving forward. Great to be part of this panel. Look forward to subsequent discussions. Thanks, Chirag.